look back at the rules for assigning oxidation numbers that we discussed in the lecture. We can summarize them very briefly. Element in its standard state, 0. Hydrogen, usually +1. Oxygen, usually -2. There are minor exceptions. And the sum of all the oxidation numbers equals the charge on the species. Given those, let's go through this list. P4 is the element, the oxidation number of phosphorus. All these answers are oxidation numbers of phosphorus, will be 0. pH 3, hydrogen is usually +1, so we have 3 times +1 for hydrogen. The oxidation number of phosphorus must make the sum 0. It's a neutral species. Therefore, -3 must be the oxidation number of phosphorus. A similar kind of reasoning applies to H3PO3. Let's go through it. 3 times +1 for the hydrogens. 3 times -2 for the oxygen, and the sum must equal 0. We have -6, +3, therefore -3. Sorry, +3. Be very careful. It's easy to make a slip-in sign. +3. So the phosphorus in this has an oxidation number of +3. Now let's tackle the last one. What kind of compound is this? It's a sodium salt. Sodium, group 1, +1 in all its compounds, and therefore the charge on the HPO4 ion must be -2. And now we can go about our job of assigning the oxidation number of phosphorus in this ion. Hydrogen, +1. Oxygen, (4 times -2). We are going to assign the phosphorus oxidation number, but the sum must equal -2, because that is the charge on the ion. That's one of our rules. All the oxidation numbers added up must equal the charge on the species. Therefore, we see that phosphorus must be +5. +5, +1 is +6, -8 makes -2. So in this compound, the phosphorus has a +5 oxidation number. So, in going, for example, from phosphorous acid to disodium hydrogen phosphate, that would be an oxidation of phosphorus. In going from P4 to pH 3, that would be a reduction of phosphorus. Follow the oxidation number and you will be able to tell whether the actual atom in question is undergoing oxidation or reduction or no change at all.